So, a very good morning to you, students. I think so far I have sent you the notes on equations solvable for y, but explanation uh, I haven't given to you. So now let us see the explanation on equations solvable for y. So if you have these equations p to the power n plus capital P1 p to the power n minus 1 plus p2 small p to the power n minus 2 plus dash 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 plus p suffix n minus 1 into p plus capital P suffix n equal to 0 be solvable for y, then this equation, if you have this equation which is solvable for y, then this equation can be put in the form of y is equal to f of x p equation 2. So any equation which is of this form if it can be put in the form y is equal to fxp, then you differentiate this is called an equation solvable for y. So here you differentiate this, name this the first equation as 1 and this one as 2. So you differentiate 2 with respect to x. What you get is dy dx is equal to p, and here you have to differentiate this will be equal to phi of x and then p comma dp dx. You will get this type of equation once you express y is equal to fxp and you differentiate it with respect to x. Then after differentiating this equation 2, the equation will be of this form where p here is equal to dy dx. So here this is an equation of two variables x and p. And if suppose here the solution of this variable, this equation is f, x, p and c equal to 0, then the solution of this equation 2 can be put in either of the two forms. That is, you eliminate the first one, the solution of this equation 2, name this as equation 3. So the solution of equation 2, that is this one, can be put in this form. By either of this form, you eliminate p between 2 and 3, and to obtain a solution of the form which contain x, y and c only. And number b, you solve 2 and 3 for x, y and obtain x is equal to f1 of pc and y is equal to f2 pc. As you will obtain this equation which is called the parametric, or this one as the required solution, which is in parametric form. So either this or this will be the solution. So now let us see one problem, how to solve it. How to solve any equations which is solvable for y, or y is equal to f of xp. So for example, this equation, we have y plus px is equal to p square x to the power 4. Or you can write y here is equal to p square into x to the power 4. Bring this to this side, will become minus px. So which is of the form y is equal to f of x p, where the right hand side is of the form it contains only x and p, and the left hand side it contains only y. So you name this as equation 1, and the original equation, let me name it equation 1, and this as equation 2. So differentiate 2 with respect to x. What you get is dy dx is equal, first you differentiate x, so you have 4x cubed into p square plus. Next you differentiate p by keeping x to the power 4 constant. So x to the power 4, differentiate p, you will get twice p into dp dx, minus here again you differentiate x first and then keeping x constant, you will get dp dx here. Now, or the left hand side gives you p only, because dy dx is equal to p. So this is equal to 4x cubed p square plus twice px to the power 4 into dp dx minus dp dx into x minus p. Or you can write here, bring all this term, if you bring this p to this side, will become minus p, so minus p with this minus p will become twice p minus 4, bring all this to this side, so 4x cubed p squared plus twice px to the power 4 into dp dx minus dp dx into x. Okay, when you bring this to this side, become plus equal to 0. Or now from this you take p common, so you have twice p into 1 minus 2x cubed into p plus, as you can see from here, x also is common, dp dx also, so I can take x dp dx into twice p. Okay, sorry, this is, when you bring it to this side, it become minus, so here you have, this is minus, so you have 1 minus twice p, sorry, here it should be okay, x to the power 3, because 1x I've already taken outside, into p equal to 0. Or you can write here, as you can see here, 1 minus 2x px cubed is common, so or you can factorize using factorization method, 1 to x cubed into p into twice p plus x dp dx is equal to 0. So we name this as equation 2. So from here, by neglecting this term, this first factor which does not contain dp dx, so therefore this equation 2 reduces to twice p plus x into dp dx equal to 0, or you have here twice p into dx plus x dp is equal to 0, or divide throughout by xp, so you have here 2 by x into dx plus 1 by p into dp equal to 0. So integrating this, we get log p plus 2 log x is equal to, write the constant term also in terms of c, or log p plus log x square is equal to log c, or p log p x square, because log a plus log b is equal to log a, b is equal to log c. By taking exponential on both sides, we get e to the power log of something gives you p x square only equal to c, or p here is equal to c by x square. Now putting the value of p is equal to c by x square in the original equation, that is equation 1. Equation 1 is this, y plus px is equal to p square x to the power 4. Replace by eliminating p, we will get the required solution. So what is p? P is called c by x square, substitute it in here. So therefore y plus c by x square into x is equal to x to the power 4 into c square by x to the power 4. Or you can reduce this, x square here is common, so you can write it as 1x here will be cancelled. So x to the power 4, x power 4. So what you get is yx plus c is equal to c square x is the required solution. I hope it is clear to you.